In this presentation, we're going to look at a basic probability question. And what we're going to look at is this question here. A driver passes through 3 traffic lights. The chances that he or she will be stopped at the first is 1/2, at the second, 1/3, and at the third, 1/4, independently of what happens at each of the other traffic lights. That's an important matter there, that what we have here is independent events. So the probability rule, independent events, is going to be relevant here. And so let's look at this again. So the chances that he or she will be stopped at the first. So I'm going to call this first event F. F for first, just to make it clear, rather than use a 1 ST, just use first. Second is S, and T is third. I like to use sort of very short letter names for events. Good practice. The probability of F is 0.5, the probability of S 0.33, and the probability of T 0.25. Now really, another good practice would be keep them in the same number of decimal places. I haven't done that, so should be usually about 2 decimal places each. Anyway, so we're given that information here: 1/2, 1/3, and 1/4. There we are, 1/2, 1/3, and 1/4. Also, what we might be interested in is complement probabilities. So, for example, the probability of not getting stopped, 0.5, and the probability of not getting stopped at the first, not getting stopped at the second, is, by the way, you might notice, I'll just draw it here, the complement event. There's a couple of different ways you might notate that, but this is the probability, or the event that you don't get stopped at the first traffic lights. The complement of S, the probability of the complement of S not getting stopped at the second traffic lights, 0.66. That is 1 minus 0.33, and again, just 3 decimal places for 0.75, which is 1 minus 0.25. So what we're asked, what the driver makes the entire journey, the whole journey, without getting stopped at any of the at the traffic lights, without getting stopped. Okay, so just remember that we were told that the probability, the chance that we were told the probability that they would be stopped is 1/2. This is, so what we might be interested in here in particularly is all of this information over here. Probability of F, complement of F, probability of complement of S, probability of complement of T. So this is an independent event, and let's go to a new page here. I've gone too far there, sorry, just one sec. Probability of not getting stopped at any of the traffic lights. So probability of 0 there. Probably 0 traffic lights. Probably would have been more in keeping with my notation. Is the probability of not getting stopped at the first, which is 0.5, times the probability of not getting stopped at the second, which is 0.66. And probability of not getting stopped at the third is 0.75. Now, just as sort of remark, this is the rule of independent events, that probability of A, let's say we have 3 events, A, B, and C. The probability of A, B, and C happening altogether, if they're independent events, is just multiply out the probabilities. So multiply that out, bit of calculator work, and we get the answer to be, I have it written there, 0.25. Simple bit of calculator work. We are interested in also, let's go back to the next question there. The probability is the drivers only stopped at the first and third lights. what we might do first off is sort of consider, let's suppose they get stopped at the first lights only. How will we calculate that? Well, with probability of f, that they do get stopped at the first lights, but don't get stopped at either of the two others. So that would be the complement of s and the complement of t, and you work it out the same way. Now, you actually end up with the same value there, 0.25, because we're using the same numbers. Let's just say we were interested in finding the probability of only getting stopped at the second traffic lights. So this is, you don't get stopped at the first, you do get stopped at the second, probability of s, and you don't get stopped at the third. So it'll be 0.5, you don't get stopped at the first, 0.33, you do get stopped at the second, 0.75, you don't get stopped at the third. You work that out, you get 0.125. Now, so that's just a little bit of sort of a variation on the first part of the question. So I'm not actually answering the second part of the question yet, but I think you can sort of see where I'm going with this. So there's another one. I have this on the next slide. The probability of getting stopped at the third only. So I'm just going to write the second question here down at the bottom. Let's just go back and see what we were asked. Is only stopped at the first and third lights. So that is probability of, I'm going to call this event F and T. First and third. So that is probability of F times the probability of not getting stopped at the second times the probability of getting stopped at the third. Okay, so that is equal to 0.5 times the probability of not getting stopped at the second is 0.66, and probability of getting stopped at the third is 0.25. Bit of calculator work, that works out to be, I'll just write it down here in the bottom corner, 0.8, oh sorry, 0.8333, and so on. Okay, so that's the probability of getting stopped at the first and third only. Actually, just when people answer this question, they forget all about the second one for some reason. They just write probability of f times probability of t, and they forget all about this probability. They forget about everything to do with the second. You have to remember include the second in your calculation. So it's 0.083. And just check everything there. Yeah, okay. So the third question is stopped at just one set of lights only. Now, I've sort of started into this already. F of only, S only, and I also have T only. So I was using those those sort of intermediate examples just to build on to answering the second question, but I'm going to use some of that same information for answering the third question. We have the probability of F only, we have the probability of S only, and we can also find out the probability of T only. Okay, so that is 0.083. So it's actually the same as probability of getting stopped at the first and third. Okay. Now, the probability of getting stopped at one set of lights only. Okay, so I'm going to call this one only. Now, I really should sort of say probability one only. These are mutually exclusive events. What we have here. So if they are mutually exclusive events, you can simply add the probabilities together. We've actually calculated there two already, 0.125 and 0.25, 0.083. So if we want to find out the probability of getting stopped at one lights only, we simply add the probability of getting stopped at the first only, the second only, and the third only. Okay. Now just think of that in reverse. Just be very mindful of this when you start thinking about the word. When you sort of say one only, what does that mean? This is actually when you go back to the question. Just one set of lights. What does that mean? That means it's just stopped at the first, or stopped at the second, or stopped at the third only. That's as simple as that. Okay, so that answers all of these questions. I'm going to leave it there.